Rules of exponents. We're still in the unit of roots and exponents. We've spent a lot of times on roots. Now we're going to spend some time on exponents. And we're going to cover rules of exponents for a few days. It's really important. It's different enough where we're just going to have to practice a lot to get an intuition, a good feel for it. All right, so today we're going to look at multiplying and dividing powers. We're going to multiply and divide powers. Well, what's a power, you might ask? Does anybody know what a power is? A power, let me give you an example. A power is when you have a number and you multiply it by itself. You multiply it by itself so many times. That's all a power means. So for example, if I have 2 raised to the third power, that means, sorry about that, I'll let that truck go by. 2 raised to the third power means we multiply 2 by itself 3 times. 2 times 2 times 2. That's called expanding the power. Key vocabulary word, expanding the power. We're going to do that some more next week. But the 2 is your base. That's what you're multiplying. And the 3 is your exponent. That's how many times you're multiplying it. This is what you're multiplying to. That's how many times you're multiplying it. So that's basically what a power is. Power has a base and an exponent. And to expand it out, you just multiply the base the number of times your exponents tell you. All right, so I think we kind of answered this question too. What is an exponent? An exponent, in this example, would be your 3. Okay, an exponent tells you how many times you multiply. What are you multiplying? You're multiplying the base. So what does a negative exponent mean? Well, if this says I'm multiplying the base 3 times, a negative exponent means you're dividing the base that many number of times. You're dividing the number in front of it. So let's say I have, here, let me pull out get back on pen mode. Let's say I have 2 to the negative third. Well, I'm not multiplying this power by anything, am I? 2 to the negative third times what? If you're not multiplying by anything, it means you're always multiplying by 1. So that means I'm going to take 1 and I'm going to divide it by 2 3 times. Negative exponents means you're dividing the base. If there's no number in front, that just means it's 1. So I'm dividing 1 by 2, and then I'm dividing it by 2 again, and I'm dividing it by 2 a third time. Well, what's 2 times 2 times 2? That's 8. So we're dividing it 1 divided by 8. Okay. Fortunately, we're not going to worry about that so much today. We're just going to look at combining them by either multiplying or dividing powers. So far, we've just looked at one power, 2 to the third by itself. And in this one power, 2 to the negative third by itself. Well, what happens if I was to multiply these two together? Well, if I'm multiplying 2 times 2 times 2, and I'm dividing 2 times 2 times 2, what do you think that's going to be? That's going to be 1. Good. And at the end of this lesson, I'll show you how it is 1. I'll show you how it works mathematically. It all works out together. That's the beautiful thing about math. All right, so we're going to look at multiplying powers. And if we're going to multiply powers, there's only one step. You just add the exponents, add the number in the top for powers that have the same base. So let's say I have 5 to the third times 5 to the fourth. Okay, if I expand that out, that means I'm multiplying 5 3 times. That's 5 times 5 times 5. This is 5 times 5 times 5 times 5. So this is 5 times 5 times 5. And this one here means I'm multiplying 5 4 times. 1, 2, 3, 4. That's what 5 to the fourth means. So how many times am I multiplying 5? Let's count. 1, 2, 3, 4, 5, 6, 7. Oh, Mr. John, wouldn't it have been easier just to look at the exponents? Yes. 3 and 4. How many times am I multiplying 5 here? 3 times. How many times am I multiplying 5 there? 4 times. Instead of expanding them out, wasting all that ink, we can just add the exponents. So that's going to be 5 to the 3 plus 4, which is 7. And there's your answer. Okay. Well, what if I have 5 to the third, which means I'm multiplying 5 times, times 2 to the third. Can I add those together and say that's 5 to the 6? No, because the bases are different. That means multiplying 5 3 times. That means multiplying 2 3 times. We're going to talk about this tomorrow. There is a way to simplify it, but it's not by adding the exponents. Okay, so now let's go ahead and look at what happens when you divide. So dividing powers, what do you think? If multiplying power means you add the exponent, what do you think dividing powers is going to be? It means you subtract the exponents. Very good, very good. All you got to do is just subtract the exponents of the same base. Whoops. So let's say, let me get a nicer color here. Let's say I have 3 to the fifth power, and I'm going to divide it by 3 to the second power. You know, we can write it in fraction form. That means 3 times 3 times 3 times 3. Why did I pick 5? At least I didn't pick 7. Times 3. Okay? 3 to the fifth means that, right? If I write it in fraction form, 3 squared is going to be 3 times 3 expanded out. Like that. That means 3 to the fifth divided by 3 squared, right? Well, 3 divided by 3 is what? 3 divided by 3 is 1. So these cancel each other out. Just makes it 1. And these cancel each other out also makes it 1. We don't have anything left on the bottom. What do we have left on the top? We have 3 times 3 times 3. How many 3's is that? That's 3. So that's 3 to the third power. Okay? So the easier way to do it is we just subtract the exponents. I have 5 3's here, and I'm dividing out 2 of the 3's. So it's just 5 minus 2. Instead of multiplying 3 5 times and then dividing it by 3 2 times, we can just subtract the exponents. And that's going to give me 3 to the third. Now, if you actually multiply these numbers out, and I don't know what 3 to the fifth is, that's a big number, and you divided it by 3 squared, which is 9, you'd see that it would indeed equal 27, which is 3 to the third. Okay, last little thing I want to talk about with you is, what if you have an exponent of 0? What does that mean? Just let me put my mouse key on. What if I have an exponent of 0? What does that mean? So go ahead and write this down. Anything to the 0 power, let's try 3 again. 3 to the 0 power equals 1. How many times am I multiplying 3 by the number in front here? I'm multiplying it 0 times. How many times am I dividing 3? 0 times. So we're just left with 1. 0 to the 3, remember, anytime you have a number, if you don't see a coefficient, remember the coefficient is always 1. You can always multiply by 1, it doesn't change it. So how many 3's are we multiplying to 1? None of them. Okay? So, that's between dividing and multiplying anyway. Alrighty, hope that helps. So let's go back to what we talked about earlier with the 3. If I have 3, or was it 2? If I have 2 to the third power times 2 to the negative third power. In other words, I'm multiplying 2 3 times, and I'm dividing 2 3 times. They should all cancel each other out and be 0, right? And indeed they are. What is 3 minus 3? It's 0. So that's the same thing as 2 to the 0 power. And we just found out any number to the 0 power is going to be 1. That's the same thing as saying I'm multiplying by 2 3 times. And I'm dividing by 2 3 times. Okay? And these cancel out. 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. 1 times 1 times 1 is 1. Okay, let's go ahead and look at some sample problems in here. A power has a base and an exponent. Power has a base and an exponent. I'm not going to answer all of these. There is an answer key at the end of this worksheet, just for the sake of time, because this video is getting long anyway. Just remember that powers tell you how many times to multiply a number by itself. Powers tell you how many times to multiply a number by itself. The number you're multiplying is the base. The number of times that you multiply that base, how many times do you multiply the base? The exponent will tell you. If it's negative, that means you're dividing it. All right, so let's go ahead and look at this bad boy. Let's do a few example problems. Okay, all right. 2 to the third times 2 to the third. Okay, well the base is the same, so we can multiply them together. So we have 2 to the 3 plus 3, which would be 2 to the 6. Now let's look at this one. Uh-oh, number 4, the base is not the same. Or is it? Can I rewrite 9 as 3 times 3? Yes, 9 is the same thing as 3 squared. Right? It's 3 times 3. So when I rewrite it, now we have the same base. So we have a base of 3 and a base of 3. So what do we do with the exponents? We add them. So that means I'm multiplying 3 times 3 here, and I'm also multiplying 3 times 3. How many times am I multiplying 3? 4 times. 3 times 3 is 9, plus, times another 3 times another 3. Okay, so let's look. That's pretty much how you do it. Let's see about division. And clear this bad boy out and call it a day. All right, so again, I have 10 to the third divided by 10 to the second. So we're going to subtract. What is 3 minus 2? 3 minus 2 is 1. So that's 11 to the first power, which means you're going to multiply 11. You're going to multiply 1 times 11 only one time. So we're left with 11. Uh-oh, what about this one? There's a bigger number on the bottom. 11 divided by 11 to the third. Since there's not an exponent there, I know it's 1. What's 1 minus 3? Negative 2. Okay, what does that mean? That means I'm dividing by 11 2 times. So I could also rewrite that as 1 over 11 squared. I have 2 more 11s on the bottom than I do on the top. And like I said, any questions about that? Let's look at this one again below it. So I have 2 to the second, 2 to the fourth. What's 2 minus 4? That's 2 to the negative second. Uh-oh, we have a negative exponent. What does that mean? That means I'm dividing by 2 times. And there you go. Okay, again, you can check your answers at the bottom. And I hope you have a great day. I love and miss you guys.